Alright, so I just want to take a look at properties of exponents here real quick. This is the two problems from the assignment I gave you guys today, okay, or this week. And properties of exponents is actually going to be a really important topic as you guys move forward to high school. But it's something you haven't seen since the beginning of the year. So probably a lot of you forgot about it, forgot how to do it. So up on the board in these multiple different colors, I just have the properties of exponents, so I'm just going to go through what these would equal. Now, for this first one in orange, x is the base, okay? The exponent is the little number, right? So 2 and 4. Now, whenever I have same bases, and the bases are being multiplied, so x next to x, we don't write a multiplication symbol in between these, but those are both being multiplied. So whenever I have same bases being multiplied, and it does not matter if it's a variable or a number, I add exponents. So for this first one here, because it's x squared times x to the fourth, well, that's going to give me x to the sixth because I'm adding exponents. So that's what the first one would equal. The second one in green, I've got parentheses, t cubed. Outside of that, I have an exponent of 4. This is where I'm going to multiply the exponents together. So that's going to equal t to the 12th. So this is t to the 12th. So there's that one's answer. That one's answer. All right, so when I have same bases being divided, I subtract the exponents here. So in the numerator, I have b cubed. In the denominator, I have just b. Well, whenever you have just a base by itself, it's always to the first power. So when I subtract the exponents, right, 2 or 3 minus 1 is 2, right? So I get b squared for this one. Okay. The next one, it says v to the negative third power. We never want a negative exponent in our final answer. To get an exponent not to be negative, you change the location of the base. So right now, I don't write it there, but this is really v to the negative third over 1. So this is really in the numerator. Because I don't want it to have a negative exponent, I'm going to change it to be in the denominator. So I'm going to move this whole thing, the v, to the negative third to the denominator, but when I move its location, the exponent will become positive. So this one is 1 over v cubed. And the last one, the fun one, anything to the 0 power, does not matter what it is. Doesn't matter if it's a million to the 0 power. Any variable, any number to the 0 power is always 1. So this is 1. Alright, so that's a little quick rundown of the exponent properties you guys need to use. Now, I'm going to do 2 of the problems on the assignment I'm having you do this week. I picked the last 2 because why not? They looked the most fun. So, for number 11, okay, there's some key things you guys really want to, focus in here on. One of them is, look at these negative exponents here, right? 3 of them have a negative exponent. Also, another thing I would take a look at is none of them have the same base. So I'm not going to be able to use any of these properties where I have the same base. Either I'm adding or subtracting exponents, right? So actually the only 2 exponent properties you're going to use for this problem is this one right here and this one right here. So if you look, the negative 4 is to the 0 power. That's very nice and convenient because really that is just 1 right here. So this negative 4 to the 0 is just really 1. Now, do I need to have that 1 in my answer? No, I don't, right? Because any number times 1 is just that number. So I don't need to include that in my final answer. So really, this is just going to go away because it's just 1. All right, next thing. Let's tackle these negative exponents. So any base raised to a negative exponent, I have to change its location, right? So this negative 21 to the negative 4th, I have to put it in the denominator. Now, I also have to change the location of the 2 bases that are in the denominator currently, right? 3 to the negative 5th, I need to put in the numerator. 7 to the negative 9th, I need to put in the numerator. So when I go to simplify this, I'm going to get 3 to the 5th times 7 to the 9th over negative 21, put that in parentheses, to the 4th. Okay. Now, I don't have any like bases, so there's nothing else I can do to simplify this. So that's going to be my answer. And you guys should find that answer at the bottom of the page, right? So you could simply just copy and paste it for that. That's what I would do. That would be the easiest. For 12, now 12 is kind of tricky here because I have a fraction raised to a negative exponent here. So when I have 3/7 in parentheses and negative 5 on the outside, that's the same thing as saying I have 3 to the negative 5th over 7 to the negative 5th. Okay. That's what it means to have a fraction raised to a negative exponent. Now that is being multiplied by negative 21 to the negative 4th. Now keep in mind, if this was a fraction, it's going to be over 1. So it's going to be in the numerator. The next one, it's being multiplied by negative 4 squared, right? So that's also going to be in the numerator of a fraction. So here's what I want to do. I don't want 3 fractions multiplied by each other. Okay, I want to simplify this like I had the other one, where in the numerator, I had the bases multiplied over, whatever's going to be in the denominator. So, first thing I got to keep in mind, if they have a negative exponent, their location must change, okay? So that means for this first one here, you see how I have 3 to the negative 5th? That has to move. But then I also have 7 to the negative 5th. Well, that can't stay in the denominator. That has to go to the numerator. So the first 2, I have to change their location completely. So when I do that, I'm going to get 7 to the 5th power and 3 to the 5th power. But see how they switch locations? When I do that, I change their exponents from negative to positive. The next one, okay, it has negative 21 to the negative 4th. I can't have that negative 4th. So I'm going to take this whole thing and move it to the denominator. Well, if I put that in the denominator, there must be a 1 in the numerator, right? The next one, notice it has a positive exponent, so I don't have to change its location. So it's just going to be negative 4 squared. All right, last thing I'm going to do, I'm going to rewrite this as 1 fraction instead of 3 fractions being multiplied by each other. So this is going to equal 7 to the 5th power times negative 4 squared over 3 to the 5th times negative 21. Sorry, this should be a positive 4 because I moved it. It should not have stayed negative. That was my bad. So times negative 21 to the 4th power Alright, so that would be my answer for this one. Okay, I hope this was helpful. There's 2 answers to that homework assignment you guys are doing for this week. Please feel free to reach out. Let me know if you have any questions on this assignment. And I hope you guys are doing well and staying safe.